It's definitely the largest planet ever discovered. NASA researchers have just announced that this planet is actually impossible, but it really exists. B Centauri b is real, and it's beyond anything we thought possible in astronomy. With the discovery of this giant, we are once again faced with the big question of what is really possible in this universe. It seems as if the universe is constantly confronting us with extreme discoveries, new superlatives, and unsolvable puzzles. B Centauri b not only blows up everything that has gone before in terms of size, but this incredible planet also orbits two of the craziest and deadliest stars in the known universe. Jupiter is by far the largest planet in our solar system. More than 1,300 times our little Earth would fit inside the gas giant, and now imagine that B Centauri b is more than 10 times the size of our Jupiter. This planet is not only the largest we've ever discovered but also the most massive because it orbits two extremely hot B-type stars, which are among the most massive and brightest stars in the universe. The environment around these stars is actually so hostile due to strong radiation and extreme temperatures that the existence of this giant planet is a real miracle. B Centauri b was discovered by an international team of astronomers hunting for exoplanets with the European Southern Observatory's Very Large Telescope in the Chilean Atacama Desert. The Very Large Telescope is one of the most advanced optical telescopes in the world and enables observations of distant planets invisible in infrared light. Thanks to this technology, we can discover small objects such as exoplanets in the vastness of the cosmos with exceptional clarity and detail. The discovery of B Centauri b was first announced in December 2021. The discovery was not only a real surprise in terms of the size of the planet, but also an important breakthrough in the study of exoplanets that exist in multiple star systems. We only have one star in our system, and so the planets orbit around a center in a certain order. In multiple star systems, there are 2, 3, or even 4 stars that orbit each other, and their planets orbit the central star to which they belong. You can well imagine that this leads to interesting constellations and that there is more confusion in such systems. The planets are exposed to more extreme mutual influences. It looks like B Centauri b is the only exoplanet in its star system, and that's not really surprising because the environment of the stars is not exactly what you would call inviting. How could the planet form? The exciting question surrounding this unusual exoplanet is how it was able to form in such an inhospitable place in the first place. Planets are always preceded by a star, or as in this case of a binary star system, by 2 stars. According to today's astronomers, stars are formed from condensing gas clouds, and remnants of gas and dust remain around the young stars in the form of rotating disks in which planets can then form. However, in extremely hot stars such as B Centauri, the radiation from the star normally destroys the remaining disks quite quickly, and so no planets are formed. So what was different about B Centauri that allowed a planet to form, and one of this extreme size? In the large gas cloud in which the B Centauri system formed, there must have been an additional dense region that somehow withstood the extreme radiation of the young stars, and it was in this special region that the only and gigantic exoplanet in the system formed. Experts further explain the formation of B Centauri b as a direct relic of a disk instability that resembles a dramatic and violent event. In this process, the protoplanetary disk orbiting the star cools and is gravitationally broken up into one or more planet-sized fragments. Instead of gradually evolving from a small core that accumulates matter and gas, the planet is formed here practically in a rapid process under extreme conditions. This type of planet formation contrasts with the more traditional model of core accretion, in which planets evolve from the bottom up by accumulating more and more material from their surroundings. Disk instability offers an alternative explanation of how large gas giants such as B Centauri b can form in a system that is actually considered totally unfavorable for planet formation due to the intense radiation and enormous gravitational forces of the nearby mass of stars. There seems to be nothing impossible in our cosmos, and we can only marvel at the ways in which the universe finds to create bizarre objects, huge planets, and other curiosities. Alpha Centauri are not connected. B Centauri represents a much more distant and far more massive binary star system. The similarity of the names is therefore only due to their position in the same constellation region. You should also not confuse B Centauri with Beta Centauri. This star, also officially known as Hadar or Aina, is another prominent multiple-star system in the Centaurus constellation, about 390 light-years away from Earth. Beta Centauri is one of the brightest stars in the night sky, and astronomy buffs know it as part of the Southern Cross. Let's go back to B Centauri and its striking pair of extremely hot B-type stars. These stars are known for their high mass and intense radiation. Due to extreme emissions of ultraviolet and X-rays, B-type stars are some of the most massive and luminous stars in the universe, which naturally makes them particularly interesting objects for astronomers to study. In fact, the environment around the pair of stars of B Centauri is so extreme that there should be no planets there. The intense radiation from these stars is often considered so aggressive and damaging to the formation of planetary atmospheres that the existence of the exoplanet B Centauri b is truly fantastic. We have already looked at how B Centauri b could have formed under extreme conditions. Researchers believe that this planet can only survive because it now orbits far outside the center of the star. The distance between it and its central stars is, on average, 100 times greater than the distance between Jupiter and the Sun. The far-reaching orbit apparently protects the planet effectively enough from the intense radiation. Worlds of extremes, exoplanets of superlatives, B Centauri b is therefore a real peculiarity, but we are still far from knowing whether it really is the largest exoplanet in the universe. So far, we know of just over 5,000 exoplanets, which is probably a tiny percentage compared to the actual number of planets in the known universe. Although we only know a tiny number of these worlds at the moment, we have already found so many extremely wild planets that the universe can send shivers down our spines. Space is full of wonder, color, and beauty, but it's also home to extremes and places so deadly we can hardly imagine. HD 189733b is one such candidate. This distant world is known, among other things, for its extreme weather conditions, which bring storms with speeds of over 7,000 kilometers per hour. But that's not all that's really cool about this planet. The rain, made of liquid gas, which is created by the extremely high temperatures and fast winds in the atmosphere, is terrifying. Its deep blue color, caused by the scattered silicate in the atmosphere, makes HD 189733b visually attractive and unique. But let's be honest, no one would want to stop here on a trip through the universe. When it comes to extreme worlds, Kepler-10c is a must. Researchers jokingly call this exoplanet the Godzilla of the Earths. With a diameter almost that of Earth and a mass that could be up to 17 times greater, Kepler-10c completely turns our ideas of rocky worlds on their head. Its density indicates that it is mostly rocky, which makes it a mystery, as this mass also pushes the boundaries of what we know about planet formation. WASP-12b is another remarkable candidate among the extreme exoplanets. It orbits so close to its star that this Jupiter-like planet is as hot as a boiling inferno. A year on hot Jupiter lasts less than one Earth day. We have the stark opposite with OGLE 2005 BLG 390 pound, which is one of the coldest known rocky planets in the universe, with temperatures on the entire planet so far below freezing that nothing and nobody could live there. It orbits in solitude. Researchers are currently unsure whether OGLE 2005 BLG 390 pound was really born in the dire succession of star formation in the same system, or whether the icy lonely planet was captured by the star at some point as a vagabond planet and bound to it. One planet that blows all this up is J1407b, also known as Super Saturn. This exoplanet has a ring system that makes our Saturn look pale. Imagine if we only transferred the rings of this exoplanet to our solar system. We could easily see them with our own eyes from Earth. However, the gravitational pull of the planet, with its extreme rings, is so great that we would rather not be in its direct vicinity. It's another wonder of our universe how this gigantic ring system was formed. All of these discoveries are further spectacular examples of the incredible beauty and extreme diversity in our universe. Click the subscribe button now and be part of every new video.